Okay, the first thing we know is that FG is perpendicular to GI, so that makes a right angle. JI is perpendicular to IG, that makes a right angle. FH is congruent to JH, and GH is congruent to IH. Okay, so this has either got to be side angle side or HL because we've got two sides and an angle. To check if it's HL, remember you can start an arrow at the right angle and draw the arrow. It'll be pointing at the hypotenuse. So this one is pointing at this side that is marked, and that is the hypotenuse. It's not side angle side because the angle between these two sides would be the angle over here. So between these two sides, that makes this angle here. So this is going to be HL. I'm going to write that at the top here. Remember with HL, we also have to say it's a right triangle in the picture. So looking at what we have, FH is congruent to JH. That is the hypotenuse. So we already have that proved to be congruent. GH is congruent to IH. We've already got that. That's one of the legs. So all we have left is to say that this is a right triangle. So step 2 has to be that these two are right angles, because that's what we know from those sides being perpendicular. So I'm going to put angle G and angle I are right angles. And that's by the definition of perpendicular. Okay, let me zoom in a little bit. And then once we know that each of the triangles has a right angle, we can say that they are right triangles. So triangle FGH and triangle JIH are right triangles. And that is the definition of a right triangle. And so now we've said that they are right triangles, so we can cross off that part. So now we've crossed everything off of our to-do list. So we can say that the triangles are congruent. So triangle FGH is congruent to triangle JIH. And the reason is HL. That is all for that one.